Now, in this lecture, we'll find out the radius of a circle. In the drawing, we have the right triangle ABC. Inside this right triangle, we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is angle ABC, this is a right angle. This is line segment AS, that is equal to 1 unit in its length. This is line segment ST, that is equal to 3 units. And finally, this is line segment TC, that is equals to 2 times square root of 3 units in its length. And our mission is to find out the radius of this circle. So in the first step, we define the center of this circle. This point is O. And we define the radius of this circle as X. So that is the radius that we are looking for. Or in other words, we have to find out the value of X. That is the radius of this circle. Okay. In the next step, we join points O and Q together by straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of this circle, and ends at point Q, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle is equal to X according to our definition. You can implement here rule 1. Repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle and we have tangent AB. This is tangent AB. This is tangent to this circle here. At this point, point M. Point M is the point of tendency of tangent AB with this circle. And we also have the radius OM is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. Actually, we can implement rule 1 in our drawing. Why? Because in our drawing we have the radius OQ that is equal to X. The radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by straight line. OP, line segment OP is the radius of this circle that is equal to X according to our definition. You can implement here again rule 1. Why? Because we have the radius OP that is known to point P, that is the point of tendency of tangent AB in this circle. And whenever you have a radius that is known to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So inside this quadrilateral POQB, we have 1, 2 3 right angles. The sum of 3 right angles is 230 degrees. So 230 degrees plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral POQB to 360 degrees, the fourth missing angle must be equal to 90 degrees in its size. So, inside quadrilateral POQB we have 4 right angles, and any quadrilateral that has 4 right angles must be this rectangle is not a square. So we relate to this quadrilateral POQB is a rectangle. And we also note that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X because they are equal to each other. Likewise, according to the same rule, in the same rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X because they are equal to each other. So we can found out that quadrilateral POQB is not a rectangle but a square, but because of the fact that all of its sides are equal to each other. Inside of this quadrilateral is equal to X. In the next step, we define the length of this line segment AP as A. And we define the length of this line segment QC as B. Here we can implement rule 10. I'll repeat quickly on rule 10. Rule 10 is true in any circle, so in any circle, if AB is a chord, here we have AB, chord AB in the circle, and from this common external point P, we have tangent PT that is tangent to this circle here, this point T, and we have from the common external point P a straight line from chord BA, or the extended chord BA, not just the common external point P. So in this drawing, the following equation will be true, that PT equals to PA times PB. Again, PT square will be equal to PA times PB. So whenever you have a common external point P, and from the common external point P we have tangent PT, and also we have from the common external point P a straight line that creates chord AB. Then the following equation will be true, that PT square will be equal to PA times PB. Again, PT square will be equal to PA times PB. We can actually implement rule 10 in our drawing. Why? Because in our drawing, if you focus on this common external point A, from this common external point A, we have tangent AP is extended to this circle here at this point P, and for the same common extent point A, we have the extended straight line AS creates chord ST, so all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, we get that AP square will be equal to AS times AT. Again, AP square equals to AS times AT. So I write it down. According to rule 10, if we focus on the common start point A, the following equation will be true, that AP square equals to AS times AT. Again, AP square equals to AS times AT. AP is A, according to our definition, therefore AP square is A square, and it is equals to AS is 1 times 80. 80 in total equals to 1 plus 3. In conclusion, I should have found out that A square equals to 1 times 1 plus 3. So A square equals to 1 times 1 plus 3 is 4, so it is 1 times 4, that is 4. In conclusion, I should have found out that A square equals to 4, we take a root out of this equation, and finally we get that A equals to the square root of 4, that is 2. So if I found out that A equals to 2 units in its length, that is to say, line segment AP is equal to A is equal to 2 units in its length. Likewise, we implement rule 10, this common example point C. So why can you implement rule 10 at point C? Because from point C we have tangent CQ that is tangent to this circle here at point Q, and we also have the extended chord ST, not just the common start point C. So all the requirements of rule 10 are satisfied. Therefore we can implement rule 10. According to rule 10, CQ square equals to CT times CS. Repeat again. According to rule 10, CQ square equals to CT times CS. CQ is B, therefore CQ square is B square, and it is equals to CT. CT is 2 times square root of 3 times CS. CS or SC, from the drawing it is very easy to see that SC in total equals to 3 plus 2 times square root of 3. Again, SC equals to 3 plus 2 times square root of 3. So in conclusion, I should find out that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. We'll open the brackets on this side of the equation and we get that B square equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 equals to 12. Why? Because 2 times 2 is 4 and square root of 3 times square root of 3 is 3 and 3 times 4 equals to 12. So I shall find out that B square equals to 2 times 3 times square root of 3 plus 12. B square equals, we have here 12, we substitute 12 by 9 plus 3. Plus 2 times 3 times square root of 3. So this expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to the expression A square plus B square plus 2 times AB. If you just substitute A by 3 and B by square root of 3, you will get that A square plus B square plus 2 times AB equals to 9 plus 3 plus 2 times 3 times square root of 3. But this expression, A square plus B square plus 2 times AB, is equals to A plus B square and therefore this expression must be also equal to A plus B square if you substitute A by 3 and B by square root of 3. So this expression, according to this algebraic identity, equals to A plus B square, when A is 3 and B is square root of 3. So this expression equals to A plus B square. A is 3, B square root of 3 square. So those two expressions equivalent, or they are equal to each other according to this algebraic identity. But those two expressions are also equal to each other, and those two expressions are also equal to each other. Therefore, those two expressions must be also equal to each other. So if we're going to actually find out that B square equals to 3 plus square root of 3, here we take a root out of this equation, and finally we get that B equals to 3 plus square root of 3. So I shall find out that B equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus square root of 3 will be equal to 4.732 units in its length. So I actually found out that line segment QC is equal to B, according to our definition, is equals to 4.732 units in its length. And we already found out that line segment AP is equal to A according to our definition is equals to 2 units in its length. So in the next step, we will implement the Pythagoras theorem on this right big triangle, triangle ABC. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. Okay, again in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. What is the length of AC? What is the length of the hypotenuse AC? From the drawing it is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So AC in total will be equal to 4 plus 2 times square root of 3. And therefore AC square will be equal to 4 plus 2 times square root of 3 square. AC square equals to 4 plus 2 times square root of 3 square. And it is equals to AB square. AB, from the drawing it is very easy to see that AB equals to x plus 2. Therefore AB square equals to x plus 2 square. Plus BC square. From the drawing it is very easy to see that BC equals to x plus 4.732, therefore BC square equals to x plus 4.732 square. So I actually found out that x 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. And 4 plus 2 times square root of 3 square equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square, x plus 4.732 square equals to x square plus 4.732 square, that is equals to 22.3918 plus 2 times x times 4.732, that is equals to 9.464x. So in this out of the equation we have here 55.7128 0.7128. That is equals to, on the other side of the equation, we have here x squared plus x squared is 2x squared. And also here, this side of the equation, 4x plus 9.464x equals to 13.464x. And finally we have here 4 plus 22.3918 is equals to 26.3918. In conclusion, I found out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. Here we subtract 59.7128 from this equation. And we get that in this side of the equation we left with nothing, that is to say 0. That is equals to, in the other side of the equation we have here 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128 is equals to minus 29.321. So we have here a quadratic equation, that is to say 2x squared plus 13.464x minus 29.321 equals to 0 is a quadratic equation. We divide this quadratic equation by 2, and finally we get that 2x squared over 2 is x squared, and we have here 13.464x over 2 is 6.732x, and finally we have here minus 29.321 over 2 is minus 14.66, this equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now a specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0. The coefficient a equals to 1. The coefficient B equals to 6.732, and finally the coefficient C equals to minus 14.66. So we just have to put the values of A, B, and C for our specific quadratic equation. This quadratic equation, for the general formula for x equals to minus b. The general formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Repeat again, we put the values of a, b, and c for our specific quadratic equation in this general formula for x, in order to find out the value of the values of x for our specific quadratic equation, x squared plus 6.732 x minus 14.66 equals to 0. So we do it now, and we get that x equals to minus b. B is 6.732, therefore minus b is minus 6.732 plus minus the square root of b squared. B equals to 6.732, therefore b squared equals to 6.732 squared. That is equals to 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4 times c, that is minus 14.66. So in total, minus 4 times a times c is minus 4 times minus 14.66, that is plus 58.64 divided by 2a. A is 1, therefore 2a is 2 times 1, that is 2. So x equals to minus 6.732 plus minus, inside the root we have 55.3198 plus 58.64, that is actually equals to 103.9598. So inside the root we left only with 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.9598 is equals to 10.196 divided by 2. So here we will have two solutions that are possible for x. One of those two solutions are a negative solution. Why? Because of the fact that minus 6.732 minus 10.196, it is definitely a negative number. But this solution, the negative solution, is an incorrect solution. Why? Because of the fact that x, according to our definition, x is the radius of this circle. So x is a radius is a length, and therefore it must be a positive number. Therefore the negative solution for x is a correct solution. We cancel the negative solution. So we left only with the positive solution. This is possible for x. According to the positive solution, x equals to minus 6.732 plus 10.196 over 2. And minus 6.732 plus 10.196 is 3.464 divided by 2. And 3.464 over 2 is 1.732. So we actually found out that the radius x of the circle equals to 1.732 units in its length. Repeat again. The radius x of this circle is equals to 1.732 units. So in the next step, I will summarize the lecture. In this lecture, I found out the radius of this circle. So in the drawing, we have the right triangle ABC. Inside this right triangle ABC, we have this circle. And our mission is to find out the radius of this circle. In addition, we know that this is angle ABC, that is the right angle. This is line segment AS is equal to 1 unit in its length. This is line segment ST is equal to 4 units in its length. And finally, this is line segment TC is equal to 2 times cos of 4 units in its length. I repeat again that our mission is to find out the radius of this circle. So first of all, we defined the center of this circle, this point is O, and we define the radius of this circle, that is the radius that we are looking for, as x. So our mission is to find out the value of x, that is the radius of the circle. In the next step, we join points O and Q together by straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle that is equal to x. According to our definition, we implemented here rule 1. Why can implement here rule 1? Because we have the radius OQ that is on to point Q, that is the point of tendency BC. If this circle, and whenever you have a radius that is on to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to x according to our definition. Can implement here again rule 1. Why? Because we have the radius OP that is on to point P, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is on to point of tendency, whenever you have a radius that is on to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So inside this quadrilateral POQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral POQB to 360 degrees, the missing angle here must be equal to 90 degrees in its size. So inside this quadrilateral POQB, we have 4 right angles. And then the quadrilateral that has 4 right angles must be this rectangle if not a square, so relate to this quadrangle POQB is rectangle. And we also know that the opposite sides of the rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X because they are equal to each other. Likewise, according to the same rule, the same triangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X because they are equal to each other. So we shall find out that this quadrangle POQB is not a rectangle but a square, because of the fact that all of its sides are equal to each other. Each side of this quadrangle is equal to X. Therefore, this quadrangle POQB is a square. In the next step, we define this line segment AP as A, and we define this line segment QC as B. Here we implemented all 10. Repeat all 10 again quickly. According to all 10 is true in any circle, so in any circle, if AB is any chord, AB is any chord in the circle, and PT is tangent to the circle in point T, then the following equation will be true, that PT square will be equal to PA times PB, and PT square equals to PA times PB. We can actually implement rule 10 in our drawing. In our drawing, if we focus on this common external point A, from this common external point A, we have tangent AP to this circle, and we also have chord TS, so the extended chord TS touches point A, so all the requirements of rule 10 are satisfied, and therefore we can implement rule 10. According to rule 10, AP square equals to AS times AT. Again, if we focus on the common external point A, according to rule 10, AP square equals to AS times AT. AP is A, therefore AP square is A square, and it is equal to AS. AS is 1, and AT in total equals to 1 plus 3, that is 4. So in conclusion, actually found out that A square equals to 1 times 1 plus 3. So A square equals to 1 times 1 plus 3. 1 plus 3 is 4, so A square equals to 1 plus 3, that is 4. We took a root out of this equation and finally found out that A equals to the square root of 4, that is 2. Here, A equals to 2 units in its length. The next step actually implemented rule 10 on this common external point C. Right? We can implement here rule 10 because of the fact that from this common external point C we have tangent CQ, and we also have the extended chord ST touches this common external point C. So all the requirements of rule 10 are satisfied. Therefore, we can implement rule 10. According to rule 10, we get that CQ square equals to CT times CS. Again, CQ square equals to CT times CS. So in the common external point C, according to rule 10, CQ square equals to CT times CS. CQ is B, therefore CQ square is B square, and it is equal to CT. CT is 2 times root of 3 times CS. And CS in total equals to 3 plus 2 times root of 3. So in conclusion, we found out that B square equals to 2 times root of 3 times 3 plus 2 times root of 3. We open the brackets on this side of the equation, and finally found out that B square equals to 2 times 3 times root of 3, and we have 2 times root of 3 times 2 times root of 3 equals to 12. So in conclusion, we found out that B square equals to 2 times 3 times root of 3 plus 12. So B square equals to, we have here 12, we substitute 12 by 9 plus 3. And finally we found out that actually that B square equals to 9 plus 3 plus 2 times 3 times root of 3. This expression, 9 plus 3 plus 2 times 3 times root of 3 is equivalent to the expression a squared plus b squared plus 2 times ab if we just substitute a by 3 and b by root of 3. And because of the fact that a squared plus b squared plus 2 times ab equals to a plus b squared, we get that according to this algebraic identity, 9 plus 3 plus 2 times 3 times root of 3 must be also equal to a plus b squared when a equals to 3 and b equals to root of 3. A plus b squared when a equals to 3 and b equals to 3 is 3 plus root of 3 squared. Again, a plus b, and a equals to 3 and b equals to root of 3 is equals to 3 plus root of 3 squared. So those two expressions are equal to each other, and those two expressions are also equal to each other, and therefore this expression 3 plus root of 3 must be also equal to b squared. So conclusion, we found out that b squared equals to 3 plus root of 3 squared. We took root out of this equation, and finally found out that b equals to 3 plus root of 3. Root of 3 is 1.732, and therefore 3 plus root of 3 will be equal to 4.732. So in conclusion, we found out that 9 segment Q C is equal to B, it is equal actually to 4.732. And we already found out that AP is equal to A equals to 2 units in its length. In the next step, we implemented the Pythagoras theorem of this right big triangle, triangle ABC. Here by PT, the version of the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem in right triangle ABC, AC square equals to AB square plus BC square. AC equals to 4 plus 2 times root of 3, therefore AC square equals to 4 plus 2 times root of 3 square, and it is equals to AB square. AB is x plus 2, therefore AB square is x plus 2 square, plus BC square. B is x plus 4.732, therefore BC is, again, BC is x plus 0.732, therefore BC square will be equal to x plus 4.732 square. So in conclusion, we have found out that 4 plus 2 times root of 3 square equals to x plus 2 square plus x plus 4.732 square. And 4 plus 2 times root of 3 square equals to 55.3128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x. We have here plus x plus 4.732 square. X plus 4.732 square equals to x square plus 4.732 square, that is 22.3918, plus 2 times x times 4.732, that is equals to 9.464x. So here, in this side of the equation, we have 55.7128, so I copy it here. And the other side of the equation, we have here x squared plus x squared is 2x squared, and we have here 4x plus 9.46, 4x plus 9.464x equals to 13.464x, and finally we have here 4 plus 22.3918, that is equals to 26.3918. So in conclusion, I found out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. Here we subtracted 55.7128 from this equation. So in this side of the equation we left with nothing, that is to say 0. On the other side of the equation, we have here 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128 equals to minus 29.321. So in conclusion, we found out that 0 equals to 2x squared plus 13.464x minus 29.321. We divided this quadratic equation by 2, and finally found out that 2x squared over 2 is x squared plus 13.464x over 2 is 6.732x, and finally minus 29.321 over 2 is minus 14.66. So in conclusion, we found out actually that x squared plus x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus root of b squared on 4 times ac over 2a. Another specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1. The coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So we just have to put the values of a, b, and c from our specific quadratic equation. Those a, b, and c, the values of a, b, and c from this quadratic equation, from our specific quadratic equation inside this general formula for x, in order to find out the value of the values of x for our specific quadratic equation. That is to say, for this quadratic equation, x squared plus 6.732x minus 14.66 equals to 0. So we did it and found out actually that x equals to minus b. b is 6.732, therefore minus b is minus 6.732 plus minus root of b squared. b is 6.732, therefore b squared is 6.732 squared, that is 45.3198 minus 4 times a times c. So it is minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c, that is minus 14.66. So minus 4 times ac equals to minus 4 times minus 14.66, that is plus 58.64, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in conclusion, we found out that x equals to minus 6.732 plus minus square root of 45.3198 plus 58.64 divided by 2. So x equals to minus 6.732 plus minus and 45.3198 plus 58.64 equals to 103.9598 divided by 2. So inside the root we left only 103.9598. So actually found out that x equals to minus 6.732 plus minus, and the square root of 103.9598 is equals to 10.196 divided by 2. So x equals to minus 6. So we have here two solutions that are possible for x. The negative solution is irrelevant, is incorrect, because of the fact that x, according to our definition, x is the radius of this circle. So x as a radius is a length, and the length must be a positive number. Therefore, the negative solution is incorrect solution. So we take into account only the positive solution, and the positive solution for x is x equals to minus 6.732 plus 10.196 over 2. So x equals to minus 6.732 plus 10.196, that is 3.464 divided by 2. And 3.464 over 2 equals to 1.732. Solution found out that x, the radius of this circle x, equals to 1.732 units. Okay, thank you very much.